right, we're going to work through some examples using printf, print format specifiers. We'll start with how to use the specifier that works for integers, the %d, right, which will specify we want to see our output in decimal. So we'll see that we're going to put these % signs in our control string, in our printf control string. Right. There will be several other fields we can put in, but we want to start simply, right, and then learn how to build. So we're going to have a %, and then the specifier will be a character, right, from the alphabet. %d for integers, right? What it will do is it will determine how the corresponding argument, which will normally be a variable name, and the data that's stored in there, how to display that as text, right? From the specifier table, we can see that there's several different specifiers here, what their output is, right? We're going to start working with %d, which says then when we use d as our specifier, we should get it will treat the data as a signed decimal integer. Right? So let's work through some examples of that one. We'll have other tutorials where we work through a few other examples as well. Let's take a look at this printf statement here. What goes inside the double quotes is what we call our format section, or our control string. We're going to want to output these characters, sum's value is, and then we have this format specifier, this conversion specification, %d. %d is a placeholder here, and it says to convert whatever then is stored in this variable. So we have this variable named sum, or in our example, we've declared it as type int, right? And we've stored the number 4 in here. So this says to display this as a base 10 signed integer. Right? So for every one of these specifications we have, one of these specifiers, we have to have a variable name, or not just a variable name, an expression out to the right. It just could be a constant expression, a mathematical expression. Right? So it doesn't have to be a variable name. Right? Remember, everything in the computer is stored in binary, and that's why it has to be converted to a format that we understand, because we don't want to read binary. Right? Let's take a look at how we would actually do that in a program. All right. Got this code blocks example running here. Remember, whenever we use printf, we have to have # include standard.io.h. That's the library where this function printf is defined. What I've done is here, let me space that out so you can see it. Here's our variable named sum. Right? We've declared it to be of type int and initialized it with a value 4. Right? I'm simply printing a couple blank lines, so when I run the output in this, for this example, let's do build and run, that we actually get 2 blank lines to maybe make the output a little more readable. All right, so 2 blank lines at the top. Maybe I should have tabbed this over. What I want you to see here is, here's our output. So here, this printf then causes this text to be written out just exactly as it is. Sum's value is, with the spaces. Now notice there's no %d in the output. What we have in the output is a value 4. So what this did, right, this went to sum's memory. It returned the value stored in sum's memory. So this expression, sum, here evaluates to the number 4. And it takes that 4 and substitutes it in here in the %d. And then I followed this with the escape sequence, new line character, so we would have this blank line up here as well to make this output a little easier to read. Right, so that's what we do when we want to print out a signed integer in base 10, right, is we use the %d. Right, let's even see what happens if I make 4 a negative 4. Let's build and run again. And we can see then we get the negative sign out. Right? So if you notice, the other number was positive. When this was just a positive 4, it does not default to printing out the plus sign. We normally don't write numbers with plus signs in front of them. Right? Normally when we see numbers, we assume they're positive if there's no leading negative sign. So you'll see then the behavior of printf is whenever the number's negative, it will print it with a leading negative sign. If the number's positive, right, it doesn't put any sign in front of it. There are fields where you can force it to put the sign, but that's beyond the scope of this tutorial. Right. Now, that's how we get it to print out one variable. name. Right? What if we had to? Let's go ahead and change this example a little bit. Let's declare some different variables. So I've got A equals 1, B equals 2, maybe C equals -3. Right? If I want to, I can have multiple specifiers in here. Let's just change this. We're going to print the values stored in A, B, C. Right? Change this up. So my text, I like to display what I'm printing out, right, to let the user know what the output is. So if I just want to put what's in A, I've got A colon space %D. I'll say B colon space %D here, C colon space, and then %D here. All right, and maybe let me put a few spaces there so that we see the output. All right. Now, A, comma B, comma C. You don't have to leave the spaces in between these arguments. I'm doing that to try to make it a little more readable for you. But what we should see now is we'll see the value of A here, the value of B here, and the value of C here. So there's a one-to-one correspondence. The first variable in the list, its value will be substituted here. The second variable in the list, its value will be substituted here. And the third variable in the list, its value will be substituted here. So there's an ordered correspondence. It doesn't substitute the values for C in here simply because I typed C, right? Simply because it's the third thing in the list. All right, let's do build and run. And as you can see, right, we've got A, B, C. So we can have as many of these specifiers in our control string, in our format string here as we want. Right. And it's an ordered list. Let's see what happens. What happens if I put C here and A here? Right. Let's build and run that. Notice we get the text. What I've got my spaces here, A colon space, and for this first %D, we get a -3. The -3 comes from the fact that this expression, C, right, evaluates, it has -3 stored in it. So you want to be careful when you're printing things out, right, to make sure you get the order right. And same way here. Now, what we have labeled B, this %D, right, the value stored in B here, 2, actually was substituted in. What we have labeled as C in our control string, because we had A as the third argument, its value of 1 was what was displayed out here. So if you're ever running a program, right, and you get output you don't expect, one of the first things you should do is just go check to make sure that you are outputting the variable you expect. Right? If your output is incorrect, then you have other things to go check. But I always check to make sure what I'm actually printing out is what I think I'm printing out. That's just simple examples of printf. And you can have multiple printfs. If we wanted to print these in separate printfs, we could do that. If we want to put in escape sequences, so they'll show up on separate lines, we could do that, right? If I put a \n here, if I maybe start using, I'll use the tab, right? So if I get rid of my commas and I do a \n there, right? And now we build and run. Now I didn't change the order of my arguments, so I still have that strange output there for A, B, and C because it substituted in for C into there. Right? You can see we get them on separate lines. So let's go back and correct that, right? Because if I want to correctly display what's in A, I've got to make sure it substitutes in the right spot. Yes, I changed that. All right. All kinds of things then you can do with %D to display things in base 10. The next lecture then, we'll talk about how to use how to display doubles and then floats.